In this lecture, we are going to discuss logic bombs and rootkits, two particularly dangerous types of malware. So let us start with logic bombs. So logic bombs are bits of malicious code that disrupt programs, and it is usually triggered on specific event. So it is a malicious software which needs some sort of a trigger to come into action and then carry out the malicious activities. Now that event can be anything. It could be, for instance, time or date based. So say it comes into action when we are at 12 midnight on 1st January 2020, for instance. But it is not really limited to time or date. It could even be triggered on specific events. So say when the number of registered users, they pass the 1000 mark, or say the sales of the company, they exceed a certain threshold. So there is some sort of always an event which needs to trigger the logic bomb. So it's software which is just sitting there like a ticking bomb, and it is waiting for a particular event to happen. These type of attacks are particularly dangerous because they are launched usually by disgruntled ex-employees or current employees who have a grudge against the company. So these guys, they have complete insider knowledge about your network. Now this is different from an attacker or a hacker who's externally trying to penetrate your network, doing port scans and all sort of stuff and leaving a big footprint behind. Now these guys, they are already inside the system. Moreover, they are also aware about the vulnerabilities or weaknesses in the security posture of an organization. Because they are insiders, so naturally they have much more visibility about your organization, about its assets and the weak points. Sometimes they can even include people, IT professionals or programmers who are actually working on the source code of your web applications. So it's very easy for these guys to plant these logic bombs. Another factor which makes it very dangerous is that it is also very difficult to detect logic bombs because there isn't a big footprint. Now these guys are already inside the system and they can silently insert a logic bomb, which is just there ticking and waiting for the event. So in contrast to external attacks which leave a footprint, attacks by insiders such as logic bombs are more difficult to detect. Next we have rootkits. Now this is a type of malware which embeds itself deep into your system, difficult to detect and very difficult to remove as well. Now rootkits are basically hidden software that allow privileged access to the system. So the keywords are hidden and privileged access. So they allow someone to remotely control the system in clandestine mode. They conceal other malware such as keyloggers, trojans, and viruses. It is very difficult to detect rootkits. Some of the techniques which could be used to detect rootkits are basically behavioral patterns or anomalies. So what you do is that you baseline your network or your system, and you know that this network has this much traffic, or we have this much outbound traffic, this much inbound traffic, for example, the protocols used, and these are the ports which are usually used. So once you have a baseline for your system, and if you detect an abnormality or deviation from the baseline, then you are able to detect rootkits sometimes. You can also sometimes do memory dump analysis, which basically means dumping your memory into files and then, parsing through those files to detect patterns of abuse. Rootkits are particularly dangerous to remove because they hide themselves deep inside your operating system, and usually their removal entails a complete rebuild of the system. Your best defense is to keep your operating system and applications patched and up to date. In order to understand how rootkits work, you first need to understand the ring structure. So basically what happens is that we have different rings and each ring has different level of privileges. So our operating system kernel, which is the brain of the operating system and which needs to be loaded always in the memory, it resides at ring 0. Now this represents the highest level of privileges on a system, so it has complete administrative control on your system. So as the ring numbers increase, we have decreasing privileges, which means that ring 1 has more privileges than ring 2, which has more privileges than ring 3. So we have device drivers and other firmware located at ring 1 and 2, but user applications are located in ring 3, which has the least level of privileges. Now this ring structure has been designed in order to ensure safety, We don't want to provide user applications with complete administrative control of our operating system. So now what happens is that the operating system kernel obviously has access to everything and it can perform any task on your system. However, a user application, it has limited privileges. So what happens when a user application needs to access a system file or do some functionality which requires elevated privileges? What it does is that it makes a system call to the operating system kernel located in ring 0, which then does that task if it is allowed. So for instance, it can be fetching a file or launching a service. So this is how the ring structure works. Now we have different type of rootkits which could be either located in ring 0, and these type of rootkits are called kernel rootkits. They run in the most privileged mode and they can modify parts of the operating system and even the kernel itself. So basically they have full security access and they're the most dangerous types of rootkits. Or rootkits could also reside in the user ring. So these are called user mode rootkits. They run in least privileged user ring and they have multiple sources to launch infections. However, generally speaking, their damage potential is quite limited compared to kernel rootkits because they're running in ring 3, which already has least privileges. We also have some other types of rootkits. So for example, we have hardware or firmware rootkits, which basically target device firmwares. For example, the device drivers. So they target devices such as network cards, hard drives, and usually it is very difficult to remove them. So once a device has been infected by a rootkit in their firmware, so replacement remains the only option. Then we also have bootkits, which basically infect the master boot record. They are sometimes used to advance other malware. And these type of bootkits are always loaded in memory whenever the system boots. So let's summarize the different types of malware that we have studied throughout this domain. So first we have viruses, which basically self-replicate and they cause damage to systems and data that they infect. However, viruses, they don't spread around very easily. So they're mainly targeted towards the systems that they infect. In contrast, we have worms, which basically self-replicate and propagate over the network. And these are much more dangerous in terms of bringing down networks because they can grow exponentially. They don't need user intervention to actually propagate. Then we have Trojans, which look like legitimate software in order to trick users into installing them. But once on the system, they can install backdoors and allow for remote hackers to access your system. Then we have spyware, whose sole purpose is to collect confidential data such as your internet browsing history, the kind of shopping that you do online, and so on. Then we have ransomware, which is financially motivated. And this type of malware basically encrypts your key files and databases using a private key which you don't have. So once the data is encrypted, your files are encrypted, they ask for ransom in order to decrypt those files. Then we have rootkits. These are basically hidden malware that hide deep inside your operating system and they infect privileged components such as the operating system kernel. Then we have logic bombs, who are typically deployed by disgruntled ex-employees or employees who have a grudge against the company, and they get triggered on a particular event or a date. So if you compare all of these different types of malware, you can notice that a lot of the themes are recurring. So a lot of them, they open backdoors. A lot of these different types of malware, they steal information in different types. So this concludes our lecture.